think of an array as a single variable with compartments to hold multiple values, where a normal variable can only hold a single value. You can work with the array as a whole when you need to, or you can work with each element individually. So here's a graphic that shows the difference between a simple variable with a single value and an array. So in this case, value is a simple variable. It contains a single value, happens to be a string. And then the variable values contains 5 string values, numbered 0 through 4, because arrays are 0-based. You can work with the array as a whole as a single object in memory, or with individual elements as necessary. And then to fill the array, you might have done something like this line of code, using the split method of the string object, passing in a string, and then you get back an array. Then, as a collection object, arrays allow you to use a for each or for loop to operate on each element, rather than having to write individual lines of code for each variable. Let's say that you need to keep track of information about each week of the year. So you need to save some sort of integer variable or value that records some sort of information about each week. So there's a couple different ways you could do it. One way is to declare a variable, one variable for each week in the year. So here I have a total of 53 variables to find. Actually, I have 52 variables to find. I'm one short. But anyway, this was a little bit tedious code to write, even with copying and pasting and typing in the numbers and adding the second digit of the numbers and all. It took a few minutes to write this code. But now I have little repositories in memory where I'm able to save that integer value for each week of the year. The alternative is to create a single array variable using code something like this, and there's various ways to do that, and we'll be exploring the different ways of declaring and initializing arrays. But in this case, what I have is an array of integers. It's called weeks, so I can work with this. This is just a single variable. I'm able to work with that single variable in memory within my application, and it has buckets for 53 weeks of the year. 52 weeks plus the partial week. So I have room for every week and partial week of the year. And so that's where I went wrong with my variables. I really should have had a week 0 as well. But I would never write code like this anyway, so it doesn't really matter. All right, so you can already see that this is a much more terse, much more efficient syntax in order to use arrays. And as we'll proceed, you'll see that processing the data with each of those compartments of data is much easier as well. Okay, so this is a little bit more realistic example of code that you might use. So this is first array, and what it does is it creates an array containing 53 elements. It's that weeks array right there. And in this case, I'm just going to put a random number in each of those compartments. All right, so I need to instantiate the random object, declare my array variable. So now this is available, the structure is available in memory. And then I'm going to use a for loop in order to visit each one of the elements and assign a random number to it. And the number is going to be between 0 and 100. So I loop through this regular for loop starting at 0. Keep in mind that arrays are 0-based. And I'm going to keep the index value less than 53 and increment it each time through. And once this loop finishes executing, I'm going to have an array that's populated with 53 random numbers. Okay, and then if I want to display all of those numbers out to the console window, I can use another for loop like that. But because an array is a collection of objects, it's a collection object in the .NET framework, it supports enumeration, I can use a for each loop in order to loop through each of the integers within weeks. And so as it visits each element in the array, starting with the 0 index, the 1 index, 2 index, and so forth, it's going to populate I with the value in that compartment, which is going to be that random number, and it's going to display the number out to the console window. Okay, I'm going to put a breakpoint here and then run this code. And I'll press A for first array. All right, so now we've broken in the debugger on the last line of the method. And so now I can come up here to weeks, any instance of weeks that appears here, and I can drop this down and I can examine all of the values that are part of the contents of the array. So the array element 0, the index 0, has a random number of 82, then 33, then 98, and so forth. And I can go down and explore all of those individual elements. Okay, I'll go ahead and continue. And there you can see the result of running that method. So there are all my random numbers displayed out on the console window. Now, there's one thing to be aware of when you're using a for each loop like this. The for each loop provides read-only access to each element in the array when the array contains value types. For reference types, which I'm not using here, these are value types, but I can use an array of reference types. The loop does allow modification of the contents of each element, but you can't modify the reference within the array. That is, you can't change the object that's stored in each array element using a for each loop. If you need to be able to change the contents of the array, if that's why you're looping through all the values, then you need to use a for loop instead. Okay, so just be aware of that little gotcha about using for each loops. And again, you can think of an array as a simple list of values. And this shows a single dimensional array. So I have array indexes from 0 to 5, and then I have some sort of integral values as the contents of each array element. But you can have multi-dimensional arrays as well. So you can have 2 dimensions, and that's what this is going to look like. So now you have array indexes in both directions, and I can reference each of those individual elements. Essentially, this becomes an array of arrays. And that way of looking at it is useful, particularly when I start showing you some of the syntax that you can use in order to initialize the value of arrays. That really hits home that this is an array of arrays. Okay, so two-dimensional array has rows and columns of data. And then you might think of a three-dimensional array as a set of two-dimensional arrays stacked on top of each other, forming some sort of three-dimensional block of data. Now, it's harder to imagine four-dimensional arrays, although with the time element I could maybe put together a video that shows how the array varies over time, and that could be a visualization of a four-dimensional array. But then it becomes almost impossible to visualize with more than 4 dimensions. But you can have arrays that have more than 1 or 2 or 3 dimensions. In essence, you're unlimited. So the .NET runtime lets you create arrays with more than 4 dimensions, but that's just not something you're probably going to need to use all the time. There's certainly some specialized uses in science and finance where it's useful, but it's not a mainstream sort of thing. Okay, so what I'm going to do now is start looking at examples of the details of creating, filling, enumerating, and manipulating the contents of single and multi-dimensional arrays. Now, before I get into that, I want to mention that even though Visual Basic and C# provide native language support for arrays, when you create arrays, you don't need to instantiate a .NET Framework class. So that's because it's built into C#. Instead, the .NET Framework really does supply the functionality for arrays. Every array that you create inherits from the system.array class. And you'll find that although it doesn't appear that you're creating an instance of a class when you create an array, you actually have the full set of members of the system.array class at your disposal. And so a lot of the code that I'm going to be showing you now is actually using that system.array object that's sitting right behind every array that you create. Let's start by talking about how you can create and fill arrays with data. To declare an array, you really use pretty much the same syntax that you'd use for any normal variable. To indicate to the compiler that you're declaring an array, you have to include a pair of square brackets, either filled with a number of elements or left blank. If you leave the size blank, you'll need to supply it before you can use the array. Alright, so this is an example of declaring an array where I want to declare the array. It's created in memory, but I'm going to assign values to the individual elements later. Okay, so single line, looks like just about any other variable declaration that we've used so far. The only difference being is that I need to indicate that this is an array of strings, and so I have the square brackets there. And I do the same thing over here. I new up a string, and that's where I indicate that I'm going to have 4 elements in the array. And the result of that running that line of code is that it'll create an array with space for 4 string objects, with the elements numbered with indexes 0 through 3. And then to assign values to each of those variables, each of those elements, I can use code like this. So I'm going to use the instructors array, the name of the array, square bracket, and the index that I want to change, and then use the assignment operator, and in this case, assign a string. And I have to use strings because I declared them as strings. So arrays, the elements of an array, are strongly typed like any other variable that you use in a C# application. Okay, so now we have an array in memory. Let's talk about resizing arrays. The way I've declared the instructor's array, I can only have 4 elements within the array, and it's currently full. So this is presumably a roster of current instructors for some organization. But what if we bring on a new instructor? What if I need to add an instructor? What's interesting here is that C# doesn't supply a built-in means of resizing an array. And this is unlike Visual Basic, which provides its redim and redim preserve statements. In C#, if you want to resize an array and preserve its contents, you have to create a new array, copy all the existing elements, and create a new larger array, and then copy back the elements. And so that's what I'm doing in this code here. So the code starts by creating this instructor's temp. So this is a temporary working variable. It's a string array. And then I'm going to use the clone method of the instructor's array. This is one of the methods that's provided by the system.array object in the .NET framework. And that copies over all of the existing elements. Now, because the clone method has to work with different data types, it's going to return objects. And so I need to cast the return of this clone method as an array of strings. So that's what that statement is doing. So as a result, in instructor's temp, I'm going to now have a clone of that array. Okay, then I have to create a new array. So I'm newing up a string. I'm going to add 2 instructors, and so I'm going to make this have a size of 6. And I'm just going to overwrite that existing variable. So when I run this code, this is going to have a reference to this array. Now I'm creating an entirely new, different array and blowing away the reference to the old array. So I'm essentially reusing the variable. Okay, and then I use another element. This is a static element of the array object. And I'm going to copy over the contents of instructors into instructor's temp, and I need to supply the length of that array. And then I'm done with instructor's temp. I set it to null. And then finally, I now have indexes 4 and 5 available, and I can assign Ken and Eric to those positions. And so now I have an array with Don, Mary, Andy, Peter, Ken, and Eric taking up the 6 different elements within the array. All right, so I've got this array in memory. Because arrays are objects in .NET, they all inherit from system.array, as I keep saying. You can treat them like any other object reference. For example, you can assign the reference that's being held by the instructor's object, that's holding a reference to an array. You can assign that reference to that object to another object. And so in this case, I have an array of string, and it's called people. And now, people is going to hold the reference to the same array as instructors. These are reference types. So it's really important to understand that people is now, after this statement executes, does not contain a copy of instructors. Unlike the clone method that I used up here that did create a new array, this is just creating a new object variable that holds a reference to the same array as instructors. Okay, so to really demonstrate that, I'm going to change the string that's in the first element of the people array and then write out instructor 0. And as you're going to see shortly, that's going to say Tommy, because there's a single array in memory. I have two object variables that reference it. So it's very important to understand that. Okay, let's talk a little bit more about cloning an array. Now, the .NET Framework provides a number of techniques that you can use to copy the contents of one array into another. And so this is showing another example of that clone method. And it's important to understand that this method returns an array of objects. And so I need to cast those objects as a string using this technique. And essentially what's going to happen is it's going to take this array of objects that's returned by the method and cast it into an array of strings. So it's sort of operating on the complete set of elements. Kind of cool. Otherwise you have to write some convoluted code to cast each of the individual elements of the array. And then I can once again change friends of Brian. And because this friends is a copy of that, we created a clone, so now there's a new array in memory. This is not going to change the 0th element of the instructors. Okay, and that's what's emphasized in the comment there. Friends is a separate array, not a reference to the same array. Okay, so this operation is very different from that operation. Okay, so far I've been working with arrays of value types, of built-in data types into C#, strings specifically. And showed you one example of integers, and you can do that with any of the built-in types. But even though arrays do well containing simple data types, you can also add any other type as well. So the scenario here is that we have a writer object. If I go look at the code for that, it's right here. Very simple writer class. I have a place to store the name and the home state. Here's a constructor that allows me to construct a new instance of the writer and pass in the name and the home state. And I override the toString in order to say that whoever is from wherever. Okay, very simple class. But it's a separate object. And now what I can do is I can create an array of writers. It's going to have 4 elements. And then I can new up individual new writer objects. And once all of this code executes, I'm going to have an array of writers that contains references to 4 different objects. And the 4 objects have information about Don in Alaska, Mary in Florida, Ken in California, and Robert in Washington. And that shows how you can use arrays with just about any, well, not just about, with any kind of type that you can find in the .NET Framework or the ones that you create yourself.